Hello class! Today is our first day of talking about astronomy, and this is one of my favorite topics to teach. So we're going to start this unit on just our place in space. How does Earth fit in with the rest of space? So first thing we're going to talk about is what makes up the universe. So we live on Earth, and Earth is one of 8 planets that orbit the sun. Pluto's not a planet, but we'll get to why not someday later, okay? So we have 8 planets that orbit the sun. Earth is just one of those 8 planets. The sun is a star, so when we look at the sky and we see the stars, the sun is a star. It's just that we're much, much closer to the sun than the other stars, so it looks so much bigger and brighter. If we were closer to other stars, they also would be bigger and brighter. Our sun plus the planets make up the solar system. So you add the sun and the 8 planets and we get what's called the solar system, and it's our little area in space. Our solar system is part of the Milky Way galaxy. That's the picture that's in the right-hand corner of the slide. So the Milky Way galaxy is our area of space, and it's this monstrous, massive area in space. Galaxies are huge. Our solar system is just one tiny part of the Milky Way galaxy. So of that huge galaxy, we are just one star and one solar system among billions of stars within that galaxy. Okay? Our galaxy is just one of hundreds of billions of galaxies in the universe. So our Milky Way is not special. There are hundreds of billions of galaxies all throughout the universe. And the universe then, because we're talking about massive galaxies and stars and planets, the universe is huge, so big, we're really not sure how big the universe is. So we're going to go from the universe and move back down to tiny little Earth. Earth is special, even though Earth is just one of those 8 planets and very small when compared to the rest of space. Earth is unique for these reasons. I'm going to list them all first. So we have a lot of water on Earth. Most areas in space don't have water. Because water evaporates from the heat of the sun, we have clouds, and clouds allow us to have a rain cycle and a water cycle, and we get rain and snow. So we have water on Earth and water within our atmosphere. Not all planets have this. Due to our weather, because our planet was at one time a really rocky planet, all of that rock, due to the freezing and the water cycle and erosion and weathering, those rocks became soil. And the soil, water, and carbon dioxide put together allows plants to grow. So now we can have life. Plants add oxygen to the atmosphere. Oxygen is what allows humans and animals to live here. So every piece of this, the water, the soil, the clouds, the rocks, the carbon dioxide, the atmosphere, the oxygen, all of these pieces fit together to make Earth a really special place. We have an ozone layer, and that ozone layer protects us from the sun's harmful radiation. So we can be outside and not in a spacesuit, and we can live outside without getting harmful rays from the sun. You can still get a sunburn, but you're not going to get like radiation poisoning. So without any of these special features, life would not be able to exist as we know it on Earth. We would not live as we do now on Earth without any of these special features. And as far as we know, Earth is the only planet in the universe with life. There's a really good chance, because of the size and the massive size of the universe, that there's probably a really good chance that there is life somewhere else out there, but because the universe is so huge and so massive, we haven't actually found that life yet, and maybe they haven't found us either. Next one. All right, so now we're going to just get to planets, right? So we went, Earth is just one planet in the whole universe. Now we're just going to get to some of these other planets. So a planet is a spherical body that orbits the sun, and they're generally larger than other bodies in the solar system. So planets are spheres, right? Almost everything in space is spherical or round-ish because of the way these things move in space, and they move in circles, and they orbit in circles. Think about if you had a ball of silly putty and you moved it in a circle and moved it in a circle and moved it in a circle, it eventually becomes a sphere, right? Planets are that way, that they just get molded from the gravity and their motion into a sphere or a circle. Okay? Our solar system contains 8 planets, 5 dwarf planets, millions of asteroids and meteoroids and comets, all of which revolve around the sun. So the majority of everything in space revolves around the sun. Once in a while, you'll get an asteroid or comet or meteoroid that gets knocked out of its orbit and gets hurtling somewhere else into space, but most of them stay in orbit around the sun. So, of those planets, the small close ones to the sun are called terrestrial planets, and they are rocky planets, and they are Mercury, Venus, Earth, and Mars. The gas giant planets are made of gas instead of rock, and they are very large and very far from the sun, and they are Jupiter, Saturn, Uranus, and Neptune. You can say Uranus or Uranus, it doesn't matter, it's funny either way. So we will do a whole chapter later this year on just the planets in our solar system, but today is just an overview of space. Okay, of the dwarf planets now. So we used to include Pluto as a planet because it was out there in space, but Pluto's really tiny. Pluto would fit inside Russia on our own planet. So Pluto's a really tiny planet. So it's not a planet anymore. As we discovered more of space, as we learned more about space, as we developed and created more powerful telescopes, we realized Pluto is not alone as a really tiny planet. Pluto's a dwarf planet, and there are Pluto, Eris, Haumea, and Makemake that are faraway dwarf planets in a place called the Kuiper Belt, which we'll get to later. And then between Mars and Jupiter is the asteroid belt, and there's an entirely different dwarf planet there called Ceres. So Pluto right now is one of 5 dwarf planets. Again, more than possible, we are going to someday find other dwarf planets in our solar system. We just haven't found them yet. More powerful telescopes, we'll get there. All right, next thing we have in the solar system are moons. Most planets have moons. Even some of the dwarf planets have moons. And those moons are small bodies that revolve around planets or dwarf planets. So everything else is going around the sun. Moons are going around individual objects. And all of these things together, from the planets, the dwarf planets, the asteroids, the meteoroids, the comets, and the sun itself, all put together make up the solar system. And the solar system is the collection of large and small bodies that orbit our central star, the sun, and stretches across a large area of space. So the solar system is massive and still small compared to a galaxy and still like a speck compared to the universe, but to us, the solar system is massively huge. All right, so here's a picture of our solar system, and you can see if we start on the left with the sun, the first planet's Mercury, then Venus, then Earth, then Mars. Then that rocky belt in the middle is the asteroid belt, and within that asteroid belt we have one dwarf planet called Ceres. Then we have the gas giant planets, and you have in order Jupiter, Saturn, Uranus, and Neptune. And then way past Neptune you see something called the Kuiper Belt, and it's another belt, another grouping of asteroids and meteoroids that just rotate in space around the sun. Way out there in the Kuiper Belt, we find Pluto, Eris, Haumea, and Makemake. So 4 other dwarf planets are with Pluto within that Kuiper Belt orbit. And way out in the corner, if you look at the upper right-hand corner, we have comets. And outside of space, kind of surrounding our entire solar system, we have something called the Oort cloud. And this Oort cloud is full of comets, and that's where most of our comets exist. And so when we have comets that we only see once every 70 years or 100 years or 300 years, some of them or more, those comets exist way, way far out of space, and they move really fast, and we'll get to them eventually, but as they zip past things in the solar system, that's where they typically are starting from, or that Oort cloud, so way far away. But everything you see in that picture is part of our solar system. That's the whole solar system. Our solar system then becomes part of the galaxy. Okay? We'll get to galaxies next. We're going to talk about stars first. Okay? Stars are large celestial bodies that are composed of gas and emit light. So the sun and every other star you see in the night sky is basically a big ball of gas that gives off light. There's not a lot else to stars. They're really big, they're really bright, they're gassy, and that's it. They're not solid. They're very dangerous if you get too close. They give off radiation and other kinds of things, but light is their basic property. So our sun is a star. Most stars are only made of hydrogen and helium. So they're the 2 most common elements in all of space, or hydrogen and helium. Okay? Stars produce their energy deep inside their core in a process called nuclear fusion. And we'll get to this later. We'll have a whole unit on the sun and how the sun works and how we get to nuclear fusion. But just know that word will come up again later. Okay? A star's energy comes in the form of light, heat, and radiation. So when we're on Earth, we see the light, we can feel the heat, and if you're out there too long, you can experience the radiation and get skin cancer, but most of the time the ozone layer protects us, and so we can be outside and see the light and feel the heat and not automatically get radiation from the sun. Oops, I'm having technical difficulties. All right, stars vary in color, size, and temperature, and we'll get to this chapter later on stars, probably next week, on how we see stars as either little white specks in the sky or we see the sun as a big yellow ball in the sky. But stars actually have various colors, various temperatures, various sizes that we'll get to later. And the stars that we see in the sky are millions of miles away, sometimes billions of miles away. So we see them as tiny little specks, but in reality, it would take us lifetime. We could never get to one of those stars. They're so far away, and yet they're so massive that we can still see them from Earth, that they're such massive, bright objects that we see them on Earth as tiny little specks, but if we got closer, they would be huge. All right, so here's stars. In the right-hand picture, we see what the night sky looks like, and all of those stars in those pictures are millions of miles away from each other. So stars aren't close together at all. Stars are very far. And in the picture on the left, we have a constellation. We'll get to constellations later, but constellations are just pictures that we see that the stars make. Those stars are also not actually close together, but that is a picture of Orion. Orion is my favorite constellation, and it's a winter constellation, so at this time of year, it's really easy to go outside and see Orion, and it's most easily recognizable. In the very center, you can see 3 dots. Those 3 stars make up Orion's belt, and the rest of Orion, you don't always see the side arrow part, but you can usually see the 4 corner stars. And here, I'll try to see if I can highlight them for us. So this star, nope, that didn't work. And this, nope, this one, and these 3 in the middle, and this one down here, and this one down here. You can usually spot these stars, the 3 in the middle, the 2 at the top, and the 2 at the bottom, that make up Orion. And it's a really easily visible constellation, so you should probably go outside at some point at night and find Orion because it's just pretty. And now you know what you're looking for. Now we get to galaxies. So, galaxies are large collections of stars, gas, and dust held together by gravity. Yes, inside a galaxy, we have our whole solar system, all of our planets, even gigantic planets like Jupiter are within a galaxy. But there are billions of stars in a galaxy, and so we would just be considered like dust, basically. We're dust to the rest of the galaxy because we're very small. So stars, gas, dust, and all of this is held together in its same form by gravity. Small galaxies are called dwarf galaxies, and they contain hundreds of millions of stars. Large galaxies, we live in a large galaxy. The Milky Way galaxy is a very large galaxy, and it contains hundreds of billions of stars, so monstrously sized. Okay, galaxies come in 3 shapes. They can be spiral shapes, like our galaxy. The Milky Way is a spiral galaxy, and it has a center bulging out with spirally pinwheels of arms. Elliptical galaxies look like ovals or spheres, but no arms, and irregular galaxies just kind of appear like blobs. Okay. Our solar system, so everything that's within our area of space lies within the Milky Way galaxy. The very center of our galaxy, there's a supermassive black hole. We'll get to that information, again, a different day, just giving you a broad overview today. And the next closest galaxy to us is called Andromeda. Andromeda is 2.5 million light years away. So it takes light 2.5 million years to get to Andromeda from Earth. So it's very, very far away. So our galaxy is kind of alone in space. There's not a lot of stuff near it. So here are pictures of the galaxies. The one on the left, that's the Milky Way. That's a spiral galaxy. Andromeda on the right is an elliptical galaxy. So you don't see those spirally arms coming off of it. You just see one oval in the middle. And so elliptical galaxies look like just bright ovals. Spiral galaxies have the really pretty pinwheel arms. And irregular galaxies just kind of look like blobs. They're just like someone just dropped a bunch of stars in the sky and we're like, oh, that's a galaxy. All right, so we get to the universe now. So the universe is all of space and all of matter and all of the energy in it. So everything we know of, everything that we know in existence is within the universe. All the galaxies, all the stars, all the planets, every single object that is in existence is within the universe. We don't know how big the universe is. We don't know the structure of the universe. We don't know the shape of the universe. We don't even know if we're the only universe and if there's just one universe, or if outside of our universe is there another universe, because we've never actually explored that far in space to see what's outside of the universe. The universe is also expanding, so every time we even get to see a little bit further, the universe gets bigger. Oops, more difficulties. Okay. Areas in the universe where galaxies exist are called clusters. So areas where we see things are clusters, and areas where there's nothing are called voids. So empty space are called voids, and a void is literal nothing. There's nothing in a void, it's just empty space. So, quick review. Which of the following is the largest? Stars, galaxies, planets, or the universe? Your answer? Universe. Number 2. Which of the following is composed of stars, gas, and dust held together by gravity? Earth, galaxies, planets, or the universe? Your answer? Galaxies. Good, hope you got it right. And 3. Which of the following produces its own light? Stars, the sun, planets, stars, and the sun? Answer? D. Stars and the sun. And our last ones. Which of the following is not a galaxy shape? Oddly, irregular, elliptical, or spiral? Your answer? A. Oddly. Galaxies are not oddly shaped. They can be, but that's not a name for them. 5. Earth is a star, galaxy, planet, or universe? Your answer? Planet. We are a planet. And the last one, what makes Earth special? Water, animals, plants, or all of the above?